best thing about the Deep Foundations Institute is the collection of engineers, contractors, material and equipment suppliers, and academics. And so bringing everybody together means the stuff that we get done is useful and is immediately applied and is not in some out there academic corner, or it's not promotional to one type versus the other. It's really a true collection of the best of this industry.
Membership of the DFI has many benefits. As I said, there's, for the younger members particularly, there's a wealth of knowledge within the DFI's archives, if you will. The magazines, the journals, the publications. We have this organization called One Mind that we subscribe to, where there are literally thousands of documents on all aspects of deep foundation construction, design, etc. So from that point of view, it's a very, very important resource that comes free with your membership.
Learning about technical advancements, again, seeing what projects people are up to and what solutions other engineering firms have come up with, and then the networking opportunities that we get at the in-person meetings like this conference.
I think the technical committees is just another great way to get involved in DFI. You meet a lot of people in the industry that are very influential and important. They make a lot of decisions that we live by in the industry. So when you participate in a committee like that, you can see firsthand how design and construction is kind of sculpted. So it's a lot of fun, and it's a worthwhile investment.
It's an organization basically that guides not only the principles of what transpires in the Deep Foundation Institute or industry, but also brings everybody together to discuss common problems and provide solutions.
Good evening and hearty welcome to everyone for the first webinar of DFII India Groundwork Webinar Series 2024. So before we start the program, here are a few instructions. Recording of this webinar is prohibited. Participation certificates for student attendees will be emailed in approximately 2 weeks. And also the online recording of this webinar will be available in DFI of India YouTube channel in approximately 2 weeks. So you can ask your questions for the speaker anytime during the presentation in the Q&A box as shown on your screens. And coming back to the webinar, the program received more than 125 registrations from almost 9 countries. And once again, warm welcome to all of you joining from different parts of the world. So the sequence of today's webinar follows introduction of the speaker, Mr. Rudolf D'Souza, and followed by his presentation on the topic, Sustainability Considerations in Foundation Construction from Design to Execution, Understanding Environment Impact, Emerging Regulations and some examples. Then we have a Q&A session, and then we'll give some details of upcoming DFI India events. So without further delay, I would like to introduce today's speaker, Mr. Rudolf D'Souza, Knowledge Management Consultant, AFCONS Infrastructure Limited. Mr. Rudolf is an expert in sustainability, holding a prestigious diploma from the Swedish Institute and the SET Business School at Oxford University. Previously serving as the Chief Knowledge Officer of AFCONS Infrastructure, Mr. Rudolf was instrumental in integrating KM practices to enhance operational efficiency and foster innovation within the organization. Mr. Rudolph's multifaceted expertise in both sustainability and knowledge management positions himself as a catalyst for positive change, championing sustainable practices while harnessing the power of knowledge for transformation. We heartily welcome you, sir. Now I request you to kindly share your screen and start the presentation. Thank you.
Thank you, Sindhu. So good evening, everyone. Am I audible? Good evening, everyone. Am I audible?
Yes, sir, you're audible. Please continue.
Okay. Yeah. So I'm happy to be here and sharing some of my insights with you today. This image that you see on the screen, I asked AI to generate it. And what you can see, I'm a little unhappy with it. And I hope this is not the future that we have, because it shows a very isolated living, So you can see that there is no connectivity between civilizations. We are isolated in different spots. Let's hope it doesn't come to that. But that is what today's seminar and webinar is about. How can we all work together in order to prepare for the future? I'm going to cover some of these aspects, which you can see on the screen, and I would like to make it interactive. So in case you all have any questions, you all can ask at any time. Okay, Sindhu will be monitoring the Q&A, but feel free to jump in at any moment. Okay, and I want actually everyone, we should start thinking in systems. A lot of what we do it in terms of isolated or linear thinking. Sustainability requires us to think in terms of circularity, in terms of a system and how things are interconnected. And one thing that we have is we are all very stressed out, or we stress a lot on emissions. So we are actually going to look beyond emissions. So we are going to look at the environment plus social. That is what sustainability is going to be about. It's about environment sustainability. So I hope that you're prepared for thinking differently. And I hope that having joined here, you are a person who's open to exposure to new thoughts, new ways of thinking. Remember that sustainability is going to be one of the disruptive trends. I am very certain that within the next 2 to 3 years, all of you will have undergone some training in artificial intelligence. But sustainability is some area where we feel, oh, we can pick up as we go forward. Okay, today I'm going to share some thoughts with you. Now, remember one thing, that don't ever believe, am I too junior? What he's talking about, I cannot implement. I am only in execution. My boss tells me something to do and I have to execute it. No, sustainability today, actually, you are, whoever's junior is actually really going to be at the forefront as we go forward. So therefore, don't think that, okay, am I too junior? This session is, not for me and so on. Also, from this session, I want you to think beyond beyond single dimensions. We need to start multi-dimensional thinking. Okay, so that really is what the agenda is today. And I look forward that you gain something through the session. Every single day when you open the newspaper, there is something or the other about climate change. I picked this up from yesterday's paper. Now, in my session, there are going to be a lot of examples which are coming from India and maybe from Mumbai, and a lot from AFCONS. I've been associated with AFCONS now for almost 13 years. So some of the examples I'll give you will be from AFCONS, but remember that it is globally applicable. Anyone wants to share their experience on a particular example, feel free to jump in. So this happened in, yes, this was the big news in yesterday's newspaper, where the globe is grappling with extreme weather extremes. So if you see, Europe right now is undergoing what they call a cold snap. USA is undergoing a cold snap. Worse is Kashmir, which used to at this time attract a lot of tourists. They used to call it the Alps of the Asia. So Gulmarg, etc., have not had snow. They had snow, and then all the snow melted. So something strange is happening. Only today again, the snow has started in Kashmir. But last 1 month, there has been no snow whatsoever. So lot of things are happening. In Germany, they had, in Berlin, my son is based at Berlin, they had temperatures, extreme temperatures, -7, never happened in the last 25, 30 years. And now what has happened is that they are having rain and there are floods in the northern part of the country. In Australia, extreme heat. They are facing extreme heat and they expect that the bushfires will start in no time. So my question to you, what is causing climate change? If you could put your answers in the question and answer box. If I do not know how the sessions are supposed to go with the DFI, I have not attended any of the earlier sessions, but feel free to put on your microphone and, share with us. What do you think causes climate change? We'll give it a minute only. I don't want to speak too much on this, but I want to share some thoughts. So what do you think is causing climate change? Sindhu and Pranav, I cannot see the answers, so if you could just read it out to me. Has anyone put anything in the chat? So I'm going to ask you another question. If global warming is true, global warming, the whole earth is warming, why is it that winters are getting colder? Why is it that certain places are becoming colder? Okay, so if you have your thoughts, please share it in the chat or share it in the Q&A. Okay, I will answer these questions as we go forward. I want you to think a lot about what is causing climate change. One of the main reasons for climate change is the greenhouse gas effect. Everyone is talking about this. What has happened is that what is the greenhouse gas is that there has been a natural carbon cycle. So there is oxygen that is intake by human beings, then for combustion, etc. And the offtake has been carbon dioxide and other gases, of course. So we just call it greenhouse gases. There are 6 greenhouse gases as per the Kyoto Protocol that we need to focus on. Now, till 1960 or so, there was a balance between the amount of greenhouse gases that was being transpirated, expirated, etc., and which was being absorbed by the greenery or the oceans. But since 1960 to now, there's something called the Great Acceleration. Okay, so now these are all scientific terms that I'm using. It's a great acceleration. And this has been exacerbated by human beings. Okay, we've had a massive economy has grown massively since 1960 across the world. India has joined one of the countries that is getting into a developed country. Soon we'll be the 3rd biggest economy, etc. And so what has happened is that a lot of the fossil fuels from underground, so which is coal, okay, so which is oil, so those we are burning it. See, you need to understand that development has to take place. Environmentalists are not against development, but the pace at which it is taking place is causing disruption. So I will come to it as we go forward about the pace at which we are this thing. So it's called the Great Acceleration. And this has actually put the entire Earth at risk, our entire climate at risk. So far for 10,000, 12,000 years, we had what we call the Goldilocks climate. So it was within 1 degree, the temperature would not vary. That's how agriculture came about. Civilizations took place. Everything has taken place in the last 10,000 years. That is because there was a balance between the CO2 that was being generated and the absorption in the oceans, in the sinks, basically in the sinks. Okay, so this is the carbon cycle. There are a lot of technical terms in that hidden. I am not here to explain these technical terms, but what has happened is that fossil fuels have now overwhelmed the capacity of the sinks to naturally absorb the CO2. And this is causing a problem which I will explain. So actually, in college, you would have learned about systems. So you have open system, closed system, isolated systems, which is shown by these the flask, by the beaker, and by a bottle. So we are not living in an isolated system. We are not in an isolated system. We are also not in an open system. So to an extent, we are in a closed system where effect on one aspect, where something, an effect in one area will affect the other. So the system is constantly in a state of flux. Now, if the actions and the reactions are not in balance, then the whole system goes out of whack. And this is what is happening. So because of the greenhouse gases, now we enter to the age of the Anthropocene. There are 9 tipping points. Okay, so I'm sorry, but I'm explaining a lot of the climate science here and sustainability theories. But it is important for you to know, I had asked you a question earlier, if there is global warming, then why are winters becoming colder? Why are there more droughts? There are 9 climatic cycles which control. It's like a giant air conditioner or a climate control that we have. So there are 9 different things that happen. One is the Arctic summer ice. Then is the Greenland ice sheet. Then we have the West Atlantic ice sheet. So the ice in different places, Arctic, Antarctic, and the Greenland actually is one thing that we need to see how fast it is melting. Even the Himalayan ice is another factor, but it is not that big a factor, but it affects India. Okay, then you have got the Atlantic thermohaline circulation. So this is the air circulation. So this is what is causing the cold snap. So suddenly there is a disruption because of the global warming, and then the ice instead of moving, the air circulation, the cold air moving towards the Arctic has actually come south, and this side it has started to create cold waves in the northern part of Europe. And meanwhile, the Arctic, Greenland, etc., are not getting enough of cooling, and therefore the ice is melting faster. We keep hearing about the El Nino, where the oceans are warming, and that affects the Indian monsoons. Indian monsoons is another big climatic factor. The Indian monsoons are getting affected by that. You have the West Africa monsoons. You got the Amazon rainforest, and we got the boreal forests. The boreal forests are in the Arctic Circle. So in Russia, etc., and all. They've had forest fires out there for the first time. They've had forest fires. So you can imagine how the entire climate system is going out of whack because we are in a system. We are in a closed system. And therefore, the emissions is what is actually causing climate change. And because we are, these 9 tipping points are getting affected, therefore the climate change is affecting everyone globally. As construction professionals or in the infrastructure, we need to remember this 40, 40, 40. So what is 40, 40, 40? Let me explain. 40, the first 40 is that when you talk of emissions, there are different sectors that emit. There's agriculture that emits, there is the cattle, etc. There's industry that emit, etc. But in the construction sector, emits 40% of the emissions, the greenhouse gases come from the construction sector. At the time of construction, at the time of producing steel, cement, so the different elements that go into construction. So it is bricks, it is glass, other building materials. Together, the construction sector contributes around 34%. In India, it is 38%. As a thumb rule, we just say 40. So the whole idea is you think of 40, 40, 40, and I'll explain why we think of 40, 40, 40. So the construction sector generates 40% of the emissions. So that is the first equation. Can we look at the time of construction, at the time of design, can we look at how we can reduce the emissions? The second 40 is when the buildings, etc., the normal day-to-day running requires energy. You require, see, townships, you require factories, automobiles, everyone requires energy to be running. And it is the construction or the residential sector that picks up again 37, so around 40% of the operational energy. So can we, when we are designing, when we are doing the design of buildings, when we are doing the design of infrastructure, can we look at how can we reduce the consumption of energy? That is where we talk of green buildings, platinum buildings, etc. So BREEAM standards, etc. So therefore, this is the important part. Can we look at how can we reduce our impact of when the building is already constructed? So what can we do in that? And the third 40 is our waste generation, construction and demolition waste. When we are doing construction, a lot of extraction is taking place. You have metros that are being constructed in cities that are going underground. What is happening is that the muck that is being generated, you have tunnels, you have roads that are being constructed. So this waste, where is all this waste going? We have buildings that are getting demolished. We have roads that are being renovated, infrastructure that is being renovated. Where is this debris going? Buildings are being pulled down in order to create new buildings. So 40% of the waste, we only look at, when we look at the waste, we're looking at our landfills, and we look at this waste and see that, oh, a lot has to do with household waste and so on. But construction and demolition waste is 40%. So therefore, this is 40 time of construction, 40 at the time of operations, and 40 at the time of the demolition waste, etc., when structures are pulled down or new structures are being created. So actually buildings, etc., are energy guzzlers. So when we look at it, can we look at a different paradigm when we do our construction? And so you must have heard of something called scope 1, scope 2, scope 3. Okay, so it's very easy. Whatever is in your control, that is scope 1 emissions. So when you're doing the construction, etc., that is direct emissions by you, scope 1. Scope 2 is when you pull energy from the grid or you're using oil, diesel, etc., that is scope 2. These two are normally in your control. Scope 3 is normally out of your control. So that is the emissions that come at the time of steel, cement, when they are being manufactured, or when there is an extraction from the ground, energy is consumed, there are a lot of emissions. So actually this all accrues to this industry. Okay, you may say that, oh, this is, I cannot be responsible for the emissions that are generated during steel construction or cement. But what you could do is you could look at, can I look at vendors who supply green cement, or are there alternatives that we need to look at? And there are a lot of alternatives. Also, in terms of at the time of construction, are there carbon absorption technologies? Okay, so can I deploy those technologies? Okay, so these are some of the equations that you need to start looking at. So this is the upstream part of it. Downstream is the usage of whatever we have constructed. So as I mentioned, can we design it so that they are not energy absorbing? Okay, or they are not energy guzzlers? Okay, can I look at the design so we can use a natural airflow? I'm very impressed by do you know which is the biggest office building in the world? Till recently, it was the Pentagon in the US. And now it is the Surat Diamond Bus. And I had occasion of meeting the people who designed the Surat Diamond Bus. I was really impressed. When they did the design, they said the best part of it is because we got a free hand to do it. We did a lot of passive design. The first thing we did was construct north-south. Second, we looked at the wind flows. So there you'll find open spaces, so where the wind can interact and it can pass through the entire passages. Third is we used a lot of technology. We checked the moisture. So what has happened is at the time of design of the Surat Diamond Bus, it is such a massive building, but yet the energy intensity is lower than, I'm sure, even the flat in which you stay in. Okay, so you need to start looking at the design. Now, please forgive me if you say that, oh, I am too junior in this. I'm sorry, but sustainability is going to be your business as you go forward. Okay, there is no escape. We cannot say, oh, I am only in charge direct emissions, scope 1, and scope 2 is what I can control. Scope 3 is not in my in my control. Okay, everything today is everybody's business. That's why I said this session is going to be a little difficult. It's going to be a little different. You need to be open to new thinking, new ways of thinking. So now I'm going to look at emissions in the issue of the context of the life cycle. Okay, so here is that at the production phase, so
Excuse
where
me,
you
sir.
do the mining. Yes.
So there was a question from Dr. Sunil Pasarkar. For Scope 3
Yeah.
category, how do I know the vendors who are complying with sustainability norms, say related to the cement and reinforcement bar manufacturing?
Yes. So, Dr. Basarkar, you need to ask them for the sheets. Now, remember, the government has got, and this is across, whether it's a European Union, whether it is in US, or whether it is in India, everyone has to declare their emissions. And the government of India every 2 years certifies every plant. So in India, you have got cement plants. So you know that Dalmia Cements, this plant, this is the emissions per ton of cement. This is the emissions for this quality of cement. You can compare it with ACC, you can compare it with others, etc. So there are standards and they can share those sheets with you. We are not aware, so we don't ask for it. Similarly, for steel emissions, you must have heard about that CBAM that is coming into effect in the European Union from October. It has come into effect from 23 and it is going to become progressively difficult for exporters. So Indian companies, steel companies or Chinese companies that wish to export to the European Union have to ensure that they follow the norms that are given for the emissions. That is why in UK, Tata Steel has closed down the blast furnace of Talbot steel plant. 3,000 jobs have been lost because they say that we cannot afford to have those emissions in our balance sheet. So, Dr. Basarkar, I hope I've answered your question. Sindhu, can I move ahead?
Yes, sir, please.
So, raw materials on one side, you are able to identify products that are low, so green cement, green steel, what they call. Now they can reduce their emissions by going in for renewable energy. Okay, a lot of people are looking at renewable energy for that. But beyond that, there are technologies which are expensive. So your cost of your product may be more expensive. So we need to talk to the client and see that can they bear the cost of this and we can reduce the total emission of the project. Okay, so it is a systems thinking. Everyone has to work together, not only you, but the client, okay, the suppliers, etc., all have to work together. So at the product phase or the production phase, there are 65 to 85% of the emissions. When we do our construction, it's just about 10% of the total emissions. Okay, the construction phase. Then during the life of the product, okay, the use and life, about 15% of the emissions are there. And finally, at the end of life of the product, there is about 15 product. When I say product, I mean to say of our structures. 15% of the embodied energy is there. And so this is a very important thing to know about the life cycle of how it is affecting us. So don't use the big escape and say that we only are in charge of 10% of the emissions. So therefore, the others have to look out for it. No. We also need to look at efficiencies. Can I bring this down? Can I use renewable energy in my production? Can I change the material? Can I reduce the amount of material that I'm using? Okay, and still follow the standards. Okay, so we also need to start thinking in terms of, if you see everything is linear, that we look at production, we look at construction, we look at use, we look at end of life. Can we look at it in a circular way? Okay, so can we look at it in a system? And there are examples now coming off of how you can design things so that they can be reused in the future. Also, there are examples. I'm sure sharing on the screen on the right-hand side, you can see the MG Setu bridge. The superstructure was in bad shape. Normally, what happens is that the clients or the government says that we will demolish the entire bridge and we will reconstruct a fresh bridge. But in discussions, we managed to convince them that keep the substructure and only the superstructure. So we have created a steel truss bridge, 4.5 kilometers or 5 kilometers in length. Okay, and therefore we have retained the substructure. So this is one example where you have extended the life of the particular product. I'm sure you all will have many examples to share. I know that the Berlin airport, the old Berlin airport, when it reached its end of its life, so instead of just giving it off for development and saying that, okay, we will construct housing, we'll construct offices, etc., they started using it as a recreation park. So it's a community park. It's a massive area. Imagine 3 kilometers in length and about 5 kilometers in width. So it's oblong, but people are using it, and they've got for different activities. There's a lake, etc., and so on. So how can you reuse something at the end of its life? The Maharashtra Nature Park in Mumbai, that is somewhere around 25 acres. It was a landfill. They have now created the Maharashtra Nature Park. You've got somewhere around 150 bird species, etc. That and the oxygen that it generates because of the 25,000 trees is amazing. So similarly, when you are doing the construction, choose by alternatives. Can you look at what is the material? Can I reduce my material? Can I go in for something that looks to be expensive so you can use different advantages. I've taken two examples here from AFCONS. I've also highlighted one link so that when this presentation is shared with you, you can all Cindy, you can put it in the chat. This particular blog talks a lot about reusability, etc., circularity of materials. Okay, so one of the things is that what can we do about this? So there are two things. One is mitigation and the other is adaptation. We need to have a mitigation mindset. A mitigation mindset looks at it from the beginning. And adaptation is basically what can I do now that it is constructed? So can we start having a mitigation mindset? Can I look at things from the beginning? Okay, what can I do? This is a generic slide, so I don't have it specifically to construction, though it is partly on construction. But please start thinking of adaptation is something that happens when things are already available, and mitigation is something that I should think of at the beginning. We should all have a mitigation mindset. So here is an example of in Mumbai, Dadar area, Hind Mata was very famous for getting flooded. And for years, there was a lot of talk, what could we do? What could we do? And then finally, they took the help of the Japanese because in Tokyo, you have got this system. They've created at a nearby school an underground tank. So when it floods, when the water is in excess of 25 millimeters per hour, the excess water gets drained into this tank. It's an underground tank and it stores the water, it retains the water. So this year, Hind Mata did not flood. Okay, and then once the floods the water has receded, this water is pumped back into the stormwater drain. So it's an excellent example of mitigating, of adapting to climate change. And out here on the left, we see that after the floods in Chennai, the tenants, etc., all getting out of flood-prone areas. So I wanted to share with you an example during the recent floods in Chennai. There was this society which became very famous it was covered in the news because what happened is that it did not flood. Now, during the time of construction, they studied the flood plains. They realized they were in a flood plain. So what they did, they elevated the entire construction. And so this massive, it's a mini township, did not flood. Do you think that this is a good example of mitigation thinking or adaptation thinking? So this is actually an example of selfish thinking, because what happened is that the entire area around flooded. And this is really what is happening in our cities. We are not thinking in systems. We are not working together. Massive malls are coming up. And what we are doing is that we are constructing huge diaphragm walls wherever the water has to go, let it go as long as my society, my building, my basement does not get flooded. So this is very short-term thinking, because what is happening is that you are actually pushing out water. Soon people will not be able to enter into your area. It's going to get flooded. Okay. Here's an example of this Achal Avichal Chanchal Society in Mumbai in 2005. You know about the 924 millimeters in 12 hours. This area was flood prone, but Achal Avichal Society, even if there's 50 millimeters in an hour, it would flood. It did not flood because they had actually put in groundwater recharge systems in advance. not realizing there'll be the floods in 2005, they'd also created two ring wells. So this is an example of climate resilient structures of adaptability. So you can harness this in order to be able to move to actually handle climate resilience. Now I'm going to shift your thinking. We all like that mad over donuts. We've heard of mad over donuts. So I'm going to give you some new thinking. Okay, so this is called what we call the donut economics. I'm going to share. Remember the structure of the donut. This is one of the most important slides of my entire presentation, the donut model. So the donut actually has two. It is a body in the middle, and it has one hole in the middle and on the outer side. So in the donut model, we've got something called the ecological, the environment part of it, and the inner part is the social part of it. So far, all our concentration has been on environment part of it. Okay, so now I'm going to take you through the donut model of sustainable thinking. Okay, and I want you to pay attention and ask a lot of questions at the end of this. So in terms of the environment part of it, there are 9 different factors. Okay, so if you see on this particular model out here, you will see that there is ocean acidification. Now, wherever it is green, that is a safe operating space. Okay, so right now we've yet to cross the boundary. So ocean acidification is in control. I mentioned we are all in a system. So any one part that gets affected affects all the others. The second part is in terms of atmospheric aerosol loading. So this is basically in terms of the particles in the air. Across the world, it is below the average. In North India, we've got something called the Asian brown haze. So that is affecting climate. Okay, it's an area of concern. Globally, it is not. We have the stratospheric ozone depletion caused by the HFC and CFC gases. In 1974, there was a Munich protocol. And this is the first example of the whole world getting together to address a climate event. And basically, the ozone hole has now got blocked off, almost blocked off, because of the protocol that came in. And the use of HFCs were banned in 78 or 79. Okay, so we are now, what are this? So this is a good example of how, although in the rest, novel entities are new chemicals that are being discovered, 3,500 new chemicals that are available. These are novel, and they have percolated the groundwater, the fresh water, etc. So they are way out of control. This one part is climate change. So you can see climate change. We've discussed climate change. It's about the CO2 concentration. Climate change is only one of the 9 planetary boundaries. Then we've got the biosphere integrity, land system change, freshwater change. Freshwater is blue water and green water, and geochemical flows. Biogeochemical flows are basically fertilizers, etc. So phosphorus and nitrogen. I'm not touching upon that much. Today, I'm going to talk about climate change. We've already done that. I've mentioned about CO2, 40, 40, 40. So what we need to be doing in that area. Biosphere integrity. How do you look at the biosphere integrity of a project site when you're doing the design, when you're doing the construction? I will take you through some examples. Land system change. When we've got a road to be constructed, a tunnel, an underground, a port, what are we doing? The land system is changing. These 6 of these are already in the orange zone. So therefore, this is something that we in the sector need to be looking at very, very, very closely. Out of the 9 different planetary boundaries, we have already crossed 6. And finally, to the freshwater change. These are something that we can do something directly about. Okay, therefore, I've not talked much about novel entities or biogeochemical flows. And since the others are in control, I'm not talking about it much now. Okay, so when we look at biosphere integrity, let me give you an example. When doing a port, you had in Orissa, the olive ridley turtles was endangered. So there were certain structures created so that they would not get disturbed. Lighting was changed, etc. So this is when you're looking at the biosphere, the functional biosphere of the projects around you. We do not realize within the earth, there is a lot of earthworms, etc. Okay, and the entire, what we call the green water. We have fresh water, blue water, and we have green water. Green water is basically the moisture in the earth. Unfortunately, through construction, what we are doing is that the green water. We always look at the fresh water and saying that, oh, fresh water I've diverted. But actually, if you look at it's something that we need to destroy, especially when we create townships or we create roads, we are affecting the green water, and that is something we need to be aware of. So when we did the Samruddhi Mahamar, today you're hearing about the underpass and the overpasses for animals. Okay, so this is something that is happening. And to an extent, yes, we are taking care of the biosphere. The functional biosphere is what a term that I'm using. Okay, I'll come back to this again as we look at the social dimension also. If you have any questions, please do put it into the thing. So if you're looking at a new framework, when you're looking at the environmental parameters, there are actually 9 boundaries that you need to look at. Focus a lot on climate change, that is your emissions. We've already discussed a lot on that. Biosphere integrity. In the area in which I work, what am I doing to the ecosystem in which I am working? Okay, so am I ensuring that the insect life, the animal life, etc., is not affected, the migratory birds, etc., and therefore the entire trees, etc., and so on, are they getting affected? There's so much of news about mangroves being cut, about trees being cut, and we look at compensatory forestation. Doesn't help that local biosphere. That has got destroyed. Okay, sometimes development needs a different thinking where we can look at how can I continuously integrate my construction within the biosphere. Okay, so that is something that we need to start working on and maybe have a separate session on that. Okay. Now the social foundation, this is the inner part of the donut. Okay, the social foundation, there are 12 different things that are there. Okay, are these soft factors or hard reality? Many engineers feel that, oh, I'm not to look at these. I am an engineer. I have to construct. I have to look at, okay, environment is becoming big. But when you look at sustainability, these social factors are going to play a lot. And how do you factor these into your design? I'm going to share with you in the next slide. Recently, on the 12th of January, the Atal Setu was commissioned. It talks about dreams of connecting the third Mumbai, and it was 60 years in the making. But on the other hand, you had this fisherwoman who says, it is their dream project, but it has finished our dream. Our family income has declined. Yes, friends, what happens is that when you do certain construction, we need to look at the population around. How are we affecting them? So this has become a contentious issue. Okay, so how do we then do it? So how do we connect it? So when you look at land system change, you look at freshwater change, you look at green water change, everything is connected with the social foundation in which the project is situated in. So you have, when a road is being, or a highway project, it affects a fertile land. I remember seeing the Agra-Lucknow project at the time of construction. So much of dust went for 5 kilometers, and the area around was absolutely fertile. Crops had got destroyed because such thick layers of dust had come onto the produce of the farmers. Until the road got constructed, they were just looking in despair what is happening. And by the time the construction over in 4 years, the dust had then destroyed the fields around up to 5 kilometers on either side of the road. Okay, so this is something that can we do at the time of construction? Can we look at avoid dust rising, etc.? Can we contain it? Townships create heat islands. It destroys the green water. It destroys the biodiversity within the ground. Okay. When we create underground parking in the cities, the natural flows are getting disrupted. We look to see that my basement will not get flooded. We'll have 200 millimeters per hour. We'll have 500 millimeters in 6 hours. My basement will not get flooded. But what is happening across the city is something that we are not looking at. We are all interconnected, and that is going to come back and affect us very badly. Okay, we are doing for construction at a time, we do a lot of groundwater construction. Construction requires construction require a lot of water. We do a lot of groundwater extraction. Can we look at putting in rainwater harvesting, groundwater recharging structures for the villages in which we work in? Igatpuri, classic case, no water in the area. We had to construct check dams and give it to them. This was not charity what we were doing. We were doing it for ourselves. Okay, so this is really what you're doing. You're all interconnected. So when you're doing a project, can you look at the social? I'm giving you one example now of how this sand, when we extract sand from the river, you need to look at the planetary boundaries as well as the social boundaries. So on the lower half, you'll see that all these are the planetary boundary impacts in terms of the exacerbating the river banks. Coastal erosion is taking place. Okay, so there is so much of issues in sand mining. I have seen it for myself in Goa. My father-in-law has property along the river, and there was a lot of sand extraction. And what a way the entire area got destroyed because of sand extraction. We only focus on cement, that, okay, I'll get green cement. But what are we doing to the entire chain of the environment for the sand extraction part of it? And in terms of the social part of it, the entire fisheries, the agriculture, around the fisheries, everything got destroyed. The social equity got changed. They were laborers who were working there. There were people who had fields. They were just taken away forcefully. Okay, so this is something that is not acceptable. So when we do a project, what we can do is that do a baseline study. What are the water needs? What are the sanitation that the people in the communities up to around 3.5, 4 kilometers from our project sites have? What are the nutrition? What are the livelihoods? What are the facilities in terms of school, community center, connectivity, energy? What are the health and education? You can get NGOs to do the baseline studies for you. And what is going to be our impact of construction on their natural resources, on their livelihoods, on their social structures, on the pollution that we are generating? So we need to integrate social foundations from the design stage itself. So I hope that the donut framework, which I have shared with you, can become your framework for sustainable thinking. Thank you. And do you have any questions?
Thank you. Thank you so much, sir, for the insightful presentation. So we have two questions from the audience. Mr. Mohan was asking, in India, are there any norms for limits on carbon emissions for construction projects? Is LCA studies for projects in India, any foreign or government norms are available?
So there are norms in place. This is by the Central Pollution Control Board. So they have, and we need to follow. That's why every project has environmental, people are trained on ISO systems and as well as an environment. Okay, so there are norms in place that we need to ensure that we don't cross. But this, we should go beyond that. We should need to not just comply. We need to look at, can I look at helping out and the entire this thing ecosystem? Can I look at the societies, etc.? Okay, I hope I've answered that question, but there are norms in place.
So Mr. Mohan Ramanathan's question. In my opinion, Indian consultants and owners are not willing to pay the extra cost for low carbon footprint products, which are invariably not the cheapest. Your comments?
Yes, actually, it is an entire system that has to work. We need to talk to the principals, the government. The government is looking at, okay, we want to make India net zero by 2070. But can the government walk the talk? Can they say that, okay, you have a project which is L1, technically L1. So let's call it TL1. Can I also have one which is EL1, environmentally lowest? So what would happen is that maybe the cost could be in the range of 10%. Earlier it used to be 50%, but today costs have come down. It's just a misnomer that, okay, it's going to be very expensive. So can government start looking at having two different type of tenders? One is technically lowest and the other is environmentally technically lowest. But it needs effort on the part of the government. We ourselves cannot do it as contractors. Okay, as EPC players, our clients need to, our principals need to take the call on that also. But where it is falling within our budgets, we should do it.
So from Hemant Padalkar, is all the global sustainability issues integrated in the tenders? Companies are interested in getting the job only by lowest bidding.
See, it is not a question of companies interested in lowest bidding. The way in which tenders are designed today is all L1. Okay, technically qualified, but L1. So therefore, what I'm saying is that the entire system, so we need to, as the industry, we need to start talking to government and saying that, look, can we incorporate environmentally sound principles as well as socially sound principles into the design of the project and in the budgeting of the project. So companies would be happy to reduce, and I'm sure all engineers want to reduce their carbon emissions. Okay, as well as look at the other things in terms of, ensuring that they put in structures for recharge and ensure that they also looking after the biodiversity. But so only some companies have a conscience and say, okay, if it costs extra, we will do it.
So one comment from Mr. Sandeep. National guidelines for responsible business conduct focuses on the importance of business caring for the environment. This principle asks companies to do more than just follow the existing environmental laws. It wants them to take active steps in protecting and improving the environment. So, comment from Mr. Sandeep sir.
Right.
And Dr. Pasarkar, biggest concern of rapid construction is the carbon footprint. Even with all the precautions, do you think we as civil engineers can significantly reduce global warming? It looks pessimistic, but happy to have your comments, please.
So actually, there are two things. First, look at efficiencies. Can I ensure that the energy that we're drawing, can it be basically shifted from fossil fuels? Can I look at renewable energy? Can we talk to vendors who are supplying equipments to us that can they look at having maybe battery-based versus diesel-based, So these are some of the quick wins that you have, So these are some of the things that we need to be talking to everyone in terms of the vendors. Can we look at low-cost or less carbon-intensive cement, less carbon-intensive steel? Can we talk to the clients and say that, okay, can we make this into a model? So it is, the whole system has to work together, but these are quick wins. You need to start looking at efficiencies. Where can we start reducing the amount of material that we're using? Use material that is low in carbon intensity. Okay, and also can we look at ensuring that the energy that we draw is from renewable energy sources, either hydro, solar, etc.
So one more last question we can take, sir, due to this time constraint. So when can we expect EPD data in India, which can be used by the stakeholders for planning and design? By Mr. Alok Bhaumik.
What data?
EPD data. EPD.
EPD, I'm not familiar with the term.
So, Mr. Alok, you can contact sir personally through LinkedIn or through his email ID. So, I think we can end the Q&A session, sir, now. So, once again, thank you so much for accepting our invitation and presenting the first webinar in this Groundwork Webinar Series 2024. It was a great kickstart for the series, sir. Thank you so much.
My pleasure. I hope I've added value to all of you, and you feel free to connect up with me on LinkedIn and have your questions answered. Thank you so much.
Thank you so much, sir. So here is a quick brief about the upcoming Groundwork webinars. So usually every month we'll have a Groundwork webinar on the third Thursday. So more details will be shared soon. And for the regular updates from DFI of India, you can follow our LinkedIn page. And also, we are happy to announce our 13th annual conference of DFI of India. So it will be conducted in the party capital of India, that is Goa. So we are accepting original call for abstracts for the original technical papers. So I encourage everyone to submit an abstract for the conference. So that the deadline for the abstract submission is February 19th. And we are accepting the papers for among 8 themes as displayed on your screens. Hope to see you all in Goa this year. And this marks the end of the first webinar. Thank you all once again for joining us today. Hope to see you in the upcoming DFI events. Thank you all.